Okay, shall we move now? See, what we were discussing. Let's say there's a surface. Any surface, if you see microscopic level, any surface, if you see at the microscopic level, you will find such irregularities in the surface. Now, because of these irregularities, you can see the forces are like this. They are not on the normal. So the force this surface is applying on the object which is kept over it is known as the contact force, isn't it? These are contact forces. So this is a contact force. So in this contact force we have two components. You can draw like this. This is a normal component of the contact force. This is a contact force. This is a normal component of contact force, and this is the horizontal component of contact force. So now in between we are having an angle theta. This angle theta, which is the angle between, this is a contact force. If I write contact force, so this is contact force, this is a normal reaction, and this is the normal component of contact force, this is horizontal component of contact force. Are you getting this thing? And the angle over in between over here, this is known as angle of friction. Is it okay? This angle is known as angle of friction. Is there any doubt? So this angle becomes angle of friction, and the horizontal component of contact force becomes friction. This is friction, isn't it? And the friction is what? This is the horizontal component of contact force. Horizontal component of contact force. Is it okay? This friction.
Yeah.
Now there is a relation between coefficient of friction and angle of friction. You know that relation? What is the relation between coefficient of friction and angle of friction? This is the coefficient of friction, and this theta is the angle of friction. Let me write over here. Theta is angle of friction, and there is a relation between these two. I am erasing this. What is the relation between angle of friction and coefficient of friction? Let me write the relation. Relation between angle of friction and coefficient of friction. Angle of friction and coefficient of friction. Okay. This is the next thing. So what is the relation? Let me write the relation over here. If this is the friction, the relation is like this. Mu is equal to tan theta, or we can write tan theta is equal to mu. It's okay. Tan theta is equal to mu. This is the angle of friction, this is coefficient of friction. It's okay?
Yeah.
So this is the relation between angle of friction and coefficient of friction. And one more thing we have angle of repose. You know what is angle of repose?
No.
Yes or no?
No.
So the angle of repose is, let me draw the angle of repose also. I'm erasing this, and let's try to find out. See, angle of friction and angle of repose, they are basically same. Angle of friction is equal to angle of repose. How? What is the angle of repose? Let's say I am having an inclined plane over here. In this inclined plane, I am keeping a mass m over here. If this mass is kept on the inclined plane, there must be a minimum value of theta. The minimum value of theta at which the block starts slipping in this inclined plane. That minimum value of theta is angle of repose. I am writing it over here. What is the angle of repose? It is the minimum value of theta. It is the minimum angle. Minimum angle of the inclined plane. It is the minimum of the angle of the inclined plane at which the block kept on is just begin to slide. The block kept on it just begins to slide. Is it okay? And now what we can see, and what is the relation between angle of repose and coefficient of friction? Again, the relation between, if you see, a relation between angle of repose and coefficient of friction. What is the relation between angle of repose and coefficient of friction? It is the same. If theta is the angle of repose, the relation is same. Tan theta is equal to mu. From these two relations, you can see what you can conclude. Angle of friction is equal to angle of repose is equal to coefficient of friction. Let me write it like this. Angle of friction is equal to angle of repose is equal to coefficient of friction. Is it okay? So this is the basic idea. With these basic assumptions, we'll start with the numerical question now. So angle of friction, what you can write? You can write it at tan this thing. Okay, tan theta, that means we can write this tan theta V is equal to angle of repose. This is the relation between these, all these. Tan theta is equal to mu. You can write like this. This is the actual relation. Actually, this is okay. This is basically tan of angle of repose. This is basically not angle of repose. This is tan of friction. Tan of angle of friction or tan of angle of repose. Okay, tan of is equal to coefficient of friction. Basically, it is tan theta. Tan of angle of friction is equal to tan of angle of repose is equal to coefficient of friction. So, shall we move to the questions now? Okay, I am coming to the questions. Shall we discuss NCERT questions or we shall come to some other questions?
NCERT is fine.
Okay. Can you come to the next question? Question number 37. Shall I rub this? And now it is a question of circular motion. Question number 37. You remember centripetal force and centrifugal force while in a circular motion? What is centripetal force and centrifugal force? You have understood all these things. Shall I rub this?
Yes.
And your schools have started? Okay, so when you are having your physics exam?
My main exam started at September 11th, and after like a few weeks, physics exam is there.
Okay. So how much? What will be the marks of your exam?
So 70%, sir.
No.
70 marks.
70 marks exam, na?
Yeah.
70 marks. Okay. You know the actual date or not? In it's a weekly test or what type of test this is?
No, it's like a one-day test.
Okay. On every day there will be a test, na?
No, it's only like one day.
Okay. I'm rubbing this and coming to the next. See, question number 37. You see question number 27, you read the question and tell me how you can solve it.
What is the wall speed of 33 meter, 33 by 1.3 revolutions per minute and has a radius of 15 centimeters. The two coins are placed at the 44 and 14 centimeters away from the center of the record. We have to work with the friction between the coins and the record is 0.5. Which of the points will revolve with the record?
Okay, you got the basic idea what they are saying? They are saying a disk revolves with a speed of 33 1 by 3 revolution per minute. Now what is this? This is basically the frequency. How many revolutions per second or per minute? Okay, frequency they are giving. And has a radius of 15 centimeter. Two coins are placed at 4 centimeter and 14 centimeter away from the center of the disk. If the coefficient of friction between the coin and the disk is this, which of the two coins will fall? Which of the two coins will revolve with the disk? Now see over here. Let's draw the diagram. Here I am having a disk like this. I am making it a little bit bigger. No, let's not draw it like this. I am drawing it somewhat differently. I am drawing it in this way. I am having this disk and I am drawing in this way rather than drawing in that way. Is it okay?
Yeah.
So this is my disk, isn't it? This is the center of the disk and the disk is revolving like this. It is going like this. And what will happen, you can see from here, there are two coins placed. This disk is having a radius of 15 centimeter. One coin is placed over here at a distance of 4 centimeter from the center. Okay? And the another coin is placed over here at a distance of 14 centimeter. Is it okay? While the disk is moving, what will happen? These circles, they will also move like this, isn't it? Let me draw one more picture for this. The disk over here, like this. Okay, it is going like this. One coin over here and the another coin over here. This coin will move like this. While the disk moves, this coin will also move like this. This coin will also move like this, isn't it? Now let's talk about this coin. While the disk is moving, what is going to happen? It will experience a centrifugal force. You know about centripetal and centrifugal force? What is the centripetal and centrifugal force?
What is centrifugal, sir?
See, we are having two forces. One force is centripetal force, or we can say center seeking force. The force which is towards the center is the centripetal force, and the another force is centrifugal force. Now this centrifugal force means the force which is outside. So if I, in this diagram, if I draw these two forces, how it will be like this? The force which is towards the center is centripetal force. Is it okay? Now who is providing the centripetal force over here? The friction between the two discs, actually coin and the disc, is providing the centripetal, and it is not allowing the coin to go outside. It is making the coin moving in the circular path. The centripetal force which is acting towards the center, and the another force which is there because of the tendency of the coin to move in the straight line path. This coin will always try to move in the straight line path, isn't it? Because of the inertia of direction.
Yeah.
This coin will try to move in the straight line path always. Why it will go in a circular path? It will always have a tendency to move in the straight line path. So because of the tendency it is having to move in a straight line path, there comes a force which is in the outward direction, which is known as centrifugal force, isn't it? While studying circular motion, we have studied all these things. So this force is known as centrifugal force, which is out in the outward direction, and the force which is in the inward direction is known as centripetal force. Now the coin can move with the disc only if this centripetal force is more than or enough to counter the centrifugal force, isn't it? And if the centrifugal force is more, it will take away the coin away from the disc and it will not move with this, isn't it?
Yeah.
So here what we have to do, we need to check that the friction, and who is providing the centripetal force? The centripetal force is provided by the friction over here. And the friction force is strong enough to overcome this centrifugal force, then the coin will move, there is no problem. Centripetal, who is providing the centripetal force? Friction is providing the centripetal force. Okay? Friction between this coin and the disc. Friction, I am writing it over here. Friction between the coin and the disc is providing the centripetal force. Is it okay? Friction between the coin and the disc is providing the centripetal force. Now if the friction force, now see, the coin will revolve with the disc if the force of friction is enough to provide the necessary centripetal force, isn't it? That means, and what is the value of centrifugal force? See, in the equilibrium condition, the centrifugal force is equal to the centripetal force. In the equilibrium condition, we know equilibrium means the coin is moving in the circular path. In the equilibrium situation, the centrifugal force is balancing the centripetal force. So we know what is the value of centrifugal and centripetal. Centrifugal force is given by this expression. What is the expression for centripetal and centrifugal force? You know or you don't know? The centripetal force is given by mv square by r. You remember?
Yeah.
M is the mass of this coin, v is the linear velocity with which it is moving, and r is the radius of this path. Or we know there is a relation between linear velocity and angular velocity. V is equal to r omega. From here, if you know this omega can be written as what? It can be written as v by r, isn't it? So in place of v by r, can I write this omega? So this becomes force is equal to m omega square r, isn't it? Can I write like this? M omega square r. Can you write like this? M omega square r.
Yeah. Yeah.
So this value we can use for the centrifugal force. M omega square r. Okay. Now what should happen? The friction is providing the centripetal force. Now the friction should be more. The centrifugal force should be less than the friction force. That means what? M omega square r should be less than mu times mg, mu times this friction force, isn't it? Because friction is providing the centripetal force. If this is the situation, the coin will revolve with this disc. Is it clear?
Yeah.
So how will you find this omega? How will you find omega, and what you will write in place of omega? You can see over here, this thing and this will get cancelled. You can see over here, omega square r less than mu times g over here. This is how it is, and we know what they have given in the question. This is revolving with 33 1/3 rpm. This is the frequency they are giving. Frequency is 33 1/3 rpm. rpm means revolutions per minute. We need revolution per second. For per second, what we will do? What this thing becomes? It becomes 100/3 rpm. Okay, 100 by 3 RPM. And what we need to do? We need to find RPS, revolution per second. So the frequency will become what? Divided by 60. 100 by 3 into 60. If I write like this, what it becomes? It becomes, you can see 5 and 3. It becomes 5 by 9 revolutions per second, isn't it? RPS. I just, for finding it in seconds, revolution per second, what I did? I divided by 60. So this 0 and 0 will get cancelled. 6 will be remaining there. And 10 and 6 I cancel with 2. 5 and 3. 3 3 are 9. 5 by 9 revolutions per second. This is the frequency. From here what we can get? We can get this omega. Omega is how much? We know omega is 2 pi by t. You know this thing or not? Omega is angular velocity. Omega is angular velocity. You can write it like this. Angular displacement divided by time. Or you can write 1 by time is how much? 1 by time is equal to frequency. You can write it like this. Omega is equal to 2 pi nu. So in place of omega, what you can write? You can write 2 pi nu. So this will, you will find the value of omega. So can you find the value of omega? Put the value. Pi is how much? 22 by 7 and 5 by 9. You solve the value of omega, put it over here. How much you are getting for omega? It is 22 into, it is 10. Okay, 5 to the 10. It is, yes. Let's solve this. 220 divided by 63. How much we are getting? We are getting 3.49. Either we can solve it or we can keep it like this also. So this I am getting 3.49 radian per second. This is the unit for omega. It is radian per second, angle divided by time. So now this is what you have got till now. So now let's check in which situation this thing will happen. Okay. Till now, let's find out the value of R. Let's find out the value of R for which it will revolve. Can we find out the value of R? See over here. My R, the value of R will be how much? R is less than mu g by omega square, isn't it? R is mu g upon this, omega will come over here, omega square. If I solve the value, put the value over here, how much I will get? What is the value of mu? They have given the value of mu. Mu is the coefficient of friction. So they have given 0.15. I am writing it mu as 0.15. Now the next thing we need is G. What is the value of G we are going to put? They have given anything? Yeah, it is 9.8 meter per second. Next thing is mu G, then omega. Omega we have already found 3.49. So now let's put the value. Mu is 0.15. G is 9.8. And omega is 3.49 square. Is it okay? Now find the value of R from here. R is coming out to be, if I solve this value, 0.15 into 9.8, 0.15 into 9.8. How much I am getting? Okay. 0.15. It is 0.15 or 1.5? Okay, 0.15 into 9.8. How much I'm getting? I'm getting 1.47 over here. In the numerator I'm getting 1.47, and in the denominator you can see, it's 3.49 into 3.49. How much I'm getting? I'm getting 12.18. 12.18. Is it okay? Any problem?
No, sir.
You divide it with this. If you solve it over here, R is coming out to be less than, if I divide this value, how much I'm getting? 1.47 divided by 12.18. Okay, 1.47 divided by 12.18. I'm getting 0.12. See, I'm getting 0.12. Okay. So the R is coming out to be 0.12 meter. Okay. And if you want to convert into centimeter, multiply this distance with 100. So your R is less than 12 centimeter. Okay. R is less than 12 centimeter. This means what? If you place your coin at a distance which is less than 12 centimeter from the center, it will revolve with the disc. And if you place your coin a distance which is more than 12 centimeter, for example, one coin is placed in the at 14 centimeter point, this is not going to revolve with the disc. The coin which is placed at 4 centimeter is going to revolve with the disc. If you place your coin anywhere between 0 to 12 centimeter, it will revolve with the disc. If you place your coin at a distance which is beyond 12 centimeter, it is not going to revolve. Is it clear or not? Is there any doubt?
No, sir.
So this is what we are doing. Okay, you tell me what you understood in this, then we'll come to the next question.
Yes, I understood, sir.
Okay, that is what I'm asking, what you understood. You tell me, then we'll move to the next.
Omega centrifugal force.
See, this is centrifugal force. Centrifugal and centripetal force will be same. Centripetal force will be mv square by r. And in equilibrium situation, centripetal and centrifugal, they will be same in magnitude. So this is the centrifugal force, or let's say centripetal force. It is m omega square by r. Centrifugal force is m omega square by r. This is the force. Now you can see from here, this centrifugal force must be less than the friction force. If this centrifugal force becomes more than the friction force is providing the centripetal. So this centrifugal force must be less than the friction force. Friction is mu times normal reaction and mu times mg. Now if you come to this side, this is what is happening. Mu mg, you can see from here, m and m will get cancelled. This omega square r must be less than mu g. Now if you see over here, what will be the value of r? R should be less than this value, mu g upon omega square. Now put the value of mu g and upon omega square. What I am getting? I am getting r less than 0.12 meter. If I convert it into centimeter, multiply this by 100, what is the value you are getting? You are getting that r should be less than 12 centimeter. Is it okay?
Yeah.
You are getting r should be less than 20 centimeter, 12 centimeter. If you place your coin anywhere between 0 to 12 centimeter, the coin will revolve with the disc. If you place your coin anywhere at a distance which is more than 12 centimeter, the coin will not revolve with the disc. So here in this case, which coin you think is going to revolve with the disc? In this case, we have two coins, one at 4 centimeter and the other is 14 centimeter. Which coin will revolve with risk? Yes, the coin which is placed at distance of 4 centimeter will revolve with the disk. Okay. Now coming to the next question. Shall I come to the next question?
Yes, sir.
Okay, you see the next question. Next question, you see this question. Question number 39. Okay, let's see. Okay, let's see before that question. See question number 38. Can you read this question? Question number 38.
Yes, sir.
I'm rubbing this.
The model is located on motorcycle driving at vertical loops inside a desk when a hard spirit carrying chamber with bolts, glass factory dust and water from outside. Explain clearly why a motorcyclist is not wrong when he is at the upper most point with no support from below. What is the speed required at the uppermost position to perform a vertical loop with the radius of the chamber is 5 kilometers?
Okay. Now let's see. Why the motorcycle is not falling? Are you getting this question? What they are asking? Are you getting what they are asking?
Yeah.
What they are asking?
Asking why the motorcycle is falling when he's in the uppermost point.
See, we are having a, suppose sometimes you have seen or not, there are some rides, they go like this and they turn like this and they move on that track. The track is actually on the above, top, and they come like this, but they don't fall. While they are going like this, they don't fall. Why they are not falling actually? Although the gravitational force is pulling them, they are not falling. Why it is so? So let's try to imagine the same situation. We are having a hollow sphere over here. Here is some motorcycle over here. The person who is on this motorcycle, let's say, this motorcycle goes to the top like this. Okay. This motorcycle goes to the top. This goes like this. The person on the motorcycle goes like this. See, it is going like this. But still at this top point, it is not falling. Why it is not falling? What is the reason? See, draw the forces over here. What are the forces? mg will act in the downward direction. It will try to pull it back. Isn't it? Next thing is, when this motorcycle is going, it is applying some force on this object. It will what it will apply? It will apply a normal reaction in the downward direction. The normal reaction over here, isn't it?
Yeah.
And these two forces, they are acting in the towards the center. These two forces must be equal to the centripetal force. We know,
Yeah.
isn't it? But why it is not falling? It is not falling because while it is going, it is moving with a very high velocity. While it is moving with a very high velocity, there is a force which is acting on the outward direction, which is known as centrifugal force. Is it okay? Now this centrifugal force is actually balancing this. It is acting in the outward direction. It is balancing the normal reaction in mg. Isn't it? This is what is happening. And the centrifugal force, the magnitude of the centrifugal force must be equal to the magnitude of the centripetal force. So if I write the centripetal force, that is equal to the centrifugal force. So what will be the value of centrifugal? At the highest point you see, the normal reaction acts downward, the centripetal force is provided by the weight and the normal reaction. So if I write the centripetal force at the highest point, I write like this. At the highest point, what is happening? You can see the centripetal force. The centripetal force is equal to how much? Centripetal force is always a force which is acting towards the center, that we have already discussed. So what is acting in this in this case it is mg plus normal reaction. Let me write R plus mg. R is the force which is the normal reaction plus mg. Now you know what is the magnitude of centripetal force. It is mv square by R this side, and on this side R plus mg. This is what I am getting. Now what else they are asking? Clearly explain the motorcycle does not drop. Okay, what is the minimum speed required to perform a vertical loop if the radius of the chamber is 25 mm? Now what they are asking, what is the minimum speed which is required to perform a loop if the radius of the chamber is 25 mm? Now see, the motorcycle does not fall down due to the balancing of these forces. For minimum speed, now you see, the motorcycle is not falling because of the balancing of these forces. Because this is the centripetal force. This centripetal force is equal to the centrifugal force. You can see over here. This is the centripetal force in the downward direction, and this centripetal force, which is equal to R plus mg, should be equal to the centrifugal force, and the magnitude of the centrifugal force is equal to the centripetal force, and that's why we can write it like this. Okay, so these forces are balanced at the highest point, so it is not falling. Now the next thing is what? To move with the minimum velocity at the highest point. What should be the criteria to move with a minimum velocity? You can see this mv square by R is equal to R plus mg. Now this mg will remain the same, but this normal reaction can come to 0, isn't it? This is a normal reaction. It can become 0 or it can have any value. So this normal, if the normal reaction becomes 0, that will be the minimum velocity with which the object can move. Okay. For the object to move with minimum velocity, the normal reaction now what is the normal reaction over here? That is R should be equal to 0. If this R becomes 0, what your equation becomes like this: mv square by R becomes 0, we are left with this thing mg, isn't it? Now what they are saying, find the minimum velocity if the radius of this circular path is how much they have given? They have given 25 meter. Now you can see m and m will get cancelled. What is the minimum velocity with which it can move? V square is equal to R into G, isn't it? So V becomes what? This is how it is. You got this value? Now put the value over here. What is the value of R? It is 25. And what we can put for the G? They are giving any value? No, if they are not giving, then just simply put 9.8 and find the answer. So V becomes what? 25 into 9.8. Okay, 25 into 9.8. How much we are getting? We are getting 245. So under the root 245. So this is the value. How much is the value? If I solve the under root, I will be getting 15.65 meter per second.